Oh, whoa. I think my camera's not working. Hold up. There we go. Cool. Now you guys can see me. All right, so I guess welcome to another episode of Ferris Makes Emulators. This is episode 6. I entitled it Catching Up because it has been like, I think I counted 16 days since I did this last, which is just stupid. So a lot of this will be kind of me catching up with the project mentally as well as just kind of hacking on it. I had a pretty crazy week at work this week, so I'm also pretty scatterbrained. So again, this will probably be a slightly less focused stream like last time. But yeah, this will be fun. So I guess we'll just get into it. Cool. So now, by the way, XSKE, I'm going to start calling you Ske then. Ske? I don't know how Danish people talk. Yeah, so actually the first thing I want to do is I usually start with pull requests. So we got a couple last time, and a couple other things I actually want to talk about first, because I think I accepted a couple things. I can't remember if I went over this in the last stream or not. One thing that's really awesome is this guy called Turtle put together this really, really cool public domain ROM repository. And it just has tons of stuff in it. I've linked it in the README of the Rosendo project. So if you go into test ROMs down, or go down to test ROMs down here, you'll find the Turtle's enormous public domain ROM repository, and it is indeed enormous. Go in this ROMs folder, and there's tons of these, which is really cool. Basically, it doesn't really matter which one of these I continue using, but I believe the Fire demo is in here as well. Oh, interesting. It's actually not. So it's. Hold up. Oh yeah, here we go. Fire demo by Lack. So this is actually the ROM that I'm basically using to test so far, even though we haven't even gotten anywhere near that yet. Still working through the PIF ROM and the CPU. So I guess that's what we'll continue with today. But yeah, I just wanted to give a shout out to Turtle for putting that together because that was really, really cool. I guess he's also putting together a similar repo for documentation. Similar to what Mike Ryan's done, but I guess a little more complete. So look forward to seeing that when that's ready. So cool. Pull requests, yes. So we got a couple that I wanted to accept on the stream. This one was from Ketsuban. He's just a couple stylistic changes. I gotta refresh my mind on this as well, so I don't really remember what this was. I haven't looked at this in like a week, which is unfortunate, but I think it was just moving a couple things around, fixing some alignment things. Yeah, that's all it was. Adding a new line here in our between a couple opcodes, and then this line in our add IU instruction, just put this on a separate line. I mean, just little things, but it's nice to at least follow some kind of formatting guidelines. Of course, this led to a discussion where Crazy mentioned that we should actually probably just use Rust format. And, oh, hey, Birkenfeld. But the thing is about Rust format is that you kind of have to configure it to make it play nice with things like the crazy line breaks that I have in this project, which I kind of need to make the code at least look semi-readable on the stream. So I understand that I just need to sit there and actually do the config for it, but I haven't done that yet. So in the future, I'll probably be interested in doing that. Or if someone wants to make a pull request where they actually... Oh, no. The stream died, apparently. How much did we miss? Someone tell me the last thing I said. Sorry, guys. My connection should actually be really... My connection should actually be really stable right now because I'm wired. If it drops out again, I might have to take a break and try to fix that because that's a bummer. But where did it drop out? I want to fill you guys in. I don't think you missed that much, but still. I was going over this pull request here. This wrapping shift left 2. wanted to actually look at the code for that. View. TJS, I think it was literally as you were discussing the PR. Okay, yeah, I haven't gotten that far into that, so I think we're okay. Oh, it was me talking about Rust format. Okay, yeah, I'm actually on to the next PR. What I was saying about Rust format is that because I have like this huge font because of the stream, I have a lot of like extra line breaks and stuff. And Rust format, I gave it a quick shot, and it didn't play very nicely with all those. So if anyone wants to actually like make a config that does that, that'd be cool. I'll accept a pull request if anyone wants to do that. Otherwise, I might find the time to do it, but I'm generally pretty lazy about that kind of thing, so we'll see if that happens. Anyway, I just accepted Ketchup's pull request, so if you guys didn't hear it before, thanks to him for that. And then I started looking at this other pull request. Excuse me, which was remove unnecessary wrapping shift left in favor of just shift left 2. And this was, let me find where this was in the code again. 13. That was here. We did this this branch equal instruction, I guess. Can't remember what that L stands for. Ducati's saying, can you check if you're dropping frames? It was just my Twitch being picky. OBS says I haven't dropped any frames, and I've been live for about 27 minutes. It could be that I'm doing 1080 again. I haven't done that for a while. Not sure. Sorry about the instability. If it keeps happening, I'll look into it. But yeah, this wrapping shift left 2. It was here when we were calculating the offset with which to jump. So we took the offset sign extended, and then we shifted left 2. And the reason we did wrapping shift left 2 is because I wanted it, like, if we just do shift left 2 and it overflows, then I think we can get a panic. But it turns out I was actually kind of wrong about that. And this commit basically explains that. Wrapping shift left 2 actually wraps the operand here, the right-hand value, not the left-hand value. So it actually wouldn't have made any difference anyway. So this actually would have been the correct code. Of course, I'll undo that and accept it from the pull request. I did test something about this on the stream, but I actually can't remember what case I had. But I took another look at it after he opened the pull request, and it did seem to be correct. So yeah, I just wanted to accept this. Sindev I Love Pie is saying, oh, he just posted a simple little Vulkan hello world that prints info about the device you have that support Vulkan. Cool, I might actually play with that. But I'm pretty sure still, because I haven't done a driver update, at least since Vulkan was released, that I'm not going to have support for that, so I haven't played with that yet. I am interested in looking into Vulkan. Probably not for this project, because I'll be using, I think, Glium, I think it's called, Glium, which is a nice Rust-friendly OpenGL wrapper. Probably be using that at least at first, because I'm going to end up doing a high-level emulator for the video hardware. So, but I'm interested in playing with Vulkan just at some point when I get the chance. Anyway, I want to accept this pull request. So thanks, Freefall, for pointing this out. Cool stuff. So that's all the pull requests. Cool. There we go. Nice. And then I think I wanted to go over some of the issues. Yeah, I did open up an issue about consider using Rust format. I'll add a comment here. If anyone wants to make a config file for this, welcome to accepting APR. Okay, and a couple more of these. Hmm. Yeah, this we're storing the piff ROM in the interconnect. Let me open this stuff up again. Sorry if I'm being scatterbrained, but it's just gonna happen today. Yeah, so we're storing the piff ROM here in a vector of U8s. The thing about using a vec is that we basically said that this can be resizable, and that's not actually the best data type for the job, because that will never change size dynamically. And we went over a couple different options. One of the things you could do is, one of the things that Ketsubon opened, this issue pointed out, is that you can actually change the optimization level of the dev profile, and then it will actually... So the original reason why we did this is because, like, if you just wanted to do an array and then put it inside a Rust box, the problem is you'd have to create that array on the stack and then pass it into box's new function, which then moves that onto the heap. The problem with this is that these arrays can be fairly large. In this case, it's 4 megs, or yeah, and that can blow your stack. So I just stuck it in a vec, which will handle all of the heap allocation, everything for me. Even though it kind of encodes the wrong semantics because it also makes it resizable, which is, I'm not that terribly upset about it. RAM is the same case here. Yeah, no, the RAM is this large, not the piff ROM, but it's the same issue for both of them. The thing is, though, that you actually can, another thing that was pointed out is that you can actually create the vec with this vec syntax. Let me bump this up. You can actually create a vec with this vec syntax, and the advantage is that then the vec constructor here will guarantee that memory is allocated on the heap and never actually touches the stack, so you can't blow your stack. This suggestion came from Eamon, by the way, who's Daniel Cullen in the chat. And then you can call into box slice, which actually gives us the data type that we're looking for, which is a box with an array in it, basically, or a box with a slice in it. And that's quite cool. So I think I'll do this because then at least we get the more proper type encoded here. And even though our construction is a little maybe shoddy feeling because it goes through a vec, at least we get kind of what we wanted. There were another couple things that we went over. But basically I decided that I wanted to do this into box slice change. So I'm just going to go ahead and fix that really quick. So it's just going to be this for both of these. And this is going to be this into box slice. Cool. And I'll do this as well. Cool. So that'll bubble up. The compiler will tell me what to fix next. Whoops, git pull. That's not what I wanted to do. There we go. Yep, so now when we instantiate the interconnect, which is probably comes from n64.rs, yes it does. This needs to change as well. Should be that there. Let me do this. I know my overlays kind of block some of this output, but do that. There we go. Yeah, so this is where it's actually instantiating the n64. I believe that's in main. Yeah, here we go with piff. So what I'll actually do is I'll change this return type here, and then dot into box slice here. And that was nice and easy. Yeah, and then we have some warnings about some unused stuff. Not terribly important. And then the code runs. We get some unrecognized instructions stuff, which we expected. And I believe that this was going to be store word, if I remember correctly from where we were last time, which is going to be in here. Anyway, entity 0. Oops. Finally found that scroll bar. Oh, that's... Interface is not the greatest on this, but it'll be alright. BQ out of you. What? Oh yeah, because one of these was BQZL. Oh yeah, of course the L was likely, branch equal likely. That was this here, but of course BQZL was like a shorthand instruction for BQL. I'm just comparing these instructions in my head and getting myself caught up. One of these is going to have the upper immediate. Might have been load immediate actually. Did that as well. Let's see. Yeah, it's right here. The store word here. That's where we got to last time, and then haven't implemented this instruction yet. Cool. So I guess we'll just continue trying to get through this PIF-ROM. Yeah, sounds good. By the way, this is fixed now, so I'm actually going to commit this thing here. Let me reset my zoom. I'll redo that. This was 7. Yeah, good. Dan Collins says, check adjust to master selection. Yeah, I finally did that. Like I said, scatterbrain distracted today. We'll make it. Use box instead of yeah. So, does that actually mean something in commit messages? Is that what that's telling me? Probably does. We'll see. Sindev, I love Pi is saying interesting thing about Vulkan is you can directly emulate the target graphics hardware on the hardware of the emulating machine, which means it doesn't have to have a translation layer to OpenGL. You can literally just make a 1-1 wrapper as long as the target hardware is OpenGL compliant. That is actually a really good point. I hadn't thought about that. Totally makes sense though. Vulkan's a lot lower level, so you can just kind of implement your own graphics API on top of Vulkan. I think that's pretty cool. Like I said, I'll probably use Glium for this project first. Just because I'm not familiar with Vulkan yet, and again, driver support. But that's really cool. Again, I would love to see how that's coming along. Sindev Alapai, are you doing that on the main Citroen repo, or are you doing that somewhere else? Because I want to take a look at that. If you could link it, that'd be cool. Yeah, well, this is an issue that I want to talk about. Testing method. Ryan Hebert brought up, what are my thoughts on testing given the constraints of live streaming? Is it something that comes later or does it not fit well into the medium? Should tests be community contributions? Oh, hey, Zach. Zach's my mod, guys. Say hi to Zach. He's a rad dude. So this, yeah, the testing stuff. I basically outlined my thoughts here, but it was basically that I really don't want like unit tests and stuff for this right now. I'm not sure if that's something I'll ever actually want. Like I know we spent some time setting up Travis and AppVeyor, so maybe maybe later that's something we want to look into to actually use those services, because right now they're basically just building the code, which is still really useful. But I generally feel that because of our general lack of understanding of the hardware right now, I think tests are kind of a bad idea, because I think that they'll kind of hinder us if we have to make a lot of changes. Like in general, when you're doing emulators, your system understanding changes so much throughout the project, and I really don't want like a suite of tests that I have to update all the time to kind of hold us back. So that's kind of one reason I don't want tests. Another reason is because they'll be really hard to write. Like, I think if we just have like CPU tests, for instance, that would be fairly straightforward. But when we get into stuff like the other hardware, especially like integration tests where we test whole parts of the system, I think that will not like I really think they'll be very cumbersome to write, and I don't think we'll get a terrible amount of benefit from that. So maybe in the future it's something I want to think about more, but for now it's something I'm not very interested in. So I actually think I want to close this for now. Now that I've sort of shared my thoughts on it. Add a little comment to Turtle as well. This comment from Turtle right here is just saying you should take a look at the Emu64 and Project 64 debugger for inspiration. They're pretty decent, also fairly complete. I did check those out, and they look really rad. And I definitely want some kind of like video debugging in the sense that like we can have a wireframe mode, or we can have, you know what I mean, something like that. Yeah, because we'll need that when we start debugging anyway. In fact, I was going to build that before we actually start trying to emulate this properly, just because I think we're going to have to go through that step on our way to actually emulating the hardware, just because it will be sufficiently complex, even if it's going to be a high-level emulator. And I could be wrong about that, because again, I don't really know that much about that hardware yet. When I'm not on the stream, I'm actually doing my best to not look into like more documentation. Like I try to go find documentation, especially documentation that I think I can like show on stream and broadcast. But I try really hard not to like learn more about the system when I'm not on the stream, just because I think that's kind of the point of doing this, is to show where I get everything. So just gonna write a little note here. Okay. Another issue that was brought up was using clap for parsing command line arguments. This actually came in the form of a pull request originally, and I ended up rejecting the pull request just because I thought that this was something we should do on stream. I don't think we need to do this yet, but I definitely do want to be using this library later. And the last one that I think I didn't go over is that someone mentioned, this is Simias, I think I'm saying that right. He's actually the author of Rustation, I think it's called, which is a PlayStation emulator being written in Rust. So that's really cool. Quick tangent. Sindev, I love pie. Oh, I didn't record it, but I'm going to do another stream later today or early tomorrow. Hey, Sindev, I love pie. If you could wait till I'm done with mine so I can watch yours, that'd be really cool. I'll probably go at this for another few hours. Hadn't exactly planned a time, but probably stop around 5 or 6. So I'm interested in seeing that as well. Again, for you guys missing the chat, Sindev I love pie is working on a Vulkan like GPU emulator for the Citra emulator, and Citra is, I believe, a Nintendo 3DS emulator, which is definitely a project you guys should keep your eye on because it looks really good. So yeah, he's just saying he'll stream himself working on that stuff later, so if you want to catch more emulator streams, I would recommend that, just because I'll be watching it. It sounds really interesting to me. Like, I'm actually going to follow this guy. Cool. Anyway, so distracted today. Yeah, so this guy that's writing the Rustation emulator, he was just looking at these reset methods that we had in like the CPU. Up here, yeah, this power on reset, and also this new function. And he was saying that you know, in his emulator, he kind of went over some of the situations I discussed when I wrote these methods originally, which is that you can basically make the constructor act like a power on reset. Because if you would ever like just power on the system, like you kind of like there wouldn't really be a case where you would let me try to think about how to word this. there's never really a case where you would actually call power on reset, or I guess this is the problem case is when you call new on one of these objects and then you don't call power on reset. Whereas it could be argued that you could call power on reset at sort of any time on the object, but I mean you can really just create a new object instead as well. And the reason why this is just kind of a little bit messy is that we just have some like default values in here in the constructor that are kind of useless. We could really just say that new is also power on reset. But of course, we do actually want like a soft reset. Like if someone hits the reset button, we do want a method for that because that will actually preserve some state. But that's going to be a little bit different. So there's just a little bit of back and forth on that. And I think what I'll actually do right now before we move on is actually make that the case here, that I'm going to remove these power on reset methods. Or functions, because Rust doesn't have methods. Yeah, so I think I'll do that. I'm just going to remove the power and reset methods altogether. What was this? This was, yeah, PC. Okay. And then by the way, guys, another shout out to what I'm listening to. I think I mentioned on one of the last streams that I was listening to Camellia, who's an awesome artist. I recently discovered he put out an album in like December called Crystallized, and it's really, really good. So I'm listening to that today. Yeah, so here, we use default for this. I think the only thing it actually does is do power on reset on this reg config, this method. We could make default on there and do that as well. Yeah, because we did. Yeah, because we did default for these parts of this register. Thrasher HT, am I saying that right? I wish I understood this stuff, but I find it fascinating to watch and listen. I have been working on watching YouTube, or watching through the videos you have on YouTube right now. Cool, I'm glad you're enjoying it. Something I could do to like explain stuff more that might be helpful, as long as it doesn't slow us down too much. Mishka, oh my, the website for that artist is pretty painful. It's very Japanese. I find it charming, I think. But yeah, so I want to, in this case, we have the data transfer pattern and endianness. And as long as these match up for the default implementations, I'm just going to make that the case. I believe they do. Yeah, so those match up. So we can just get rid of power reset here. And because we derive default, we actually don't need that. So that should be good. I'm probably missing something, but the compiler will tell me. So CPU power on reset, yes, it's on N64. Oops, down here. Yeah, we call power on reset here. Not doing that anymore. And it's CPU0, that's what it was. CPU0. There we go. Thrasher HT, I understand what you're saying, but I just don't understand the code itself. I get the logic behind it. But that's cool. That's actually like all you need, really. I mean, if you're enjoying following along, it's kind of learning about the hardware. You don't really need to understand the code that much, I think. I mean, that's what's interesting to me about this. Is just like really learning about this piece of hardware that I don't really know a lot about. I think that's really fun. Even though we will end up spending some time like just refactoring stuff, which is like pure code stuff, but you know, shouldn't change your understanding of the system. Ducati, I don't understand everything either, but compared to other Twitch programmers, Ferris is the only one that appeals to me. Hey, thanks, man. Even if they code in a language I understand. Thatcher HT, I really want to learn more programming. Right now, I only know bash scripting as I'm a server admin. Bash scripting is super useful, though. I'm actually really bad at bash scripting. Ion 1, watching Ferris definitely motivated me to finally start a Rust project myself. It's a NES emulator, so rather pedestrian compared to NC4, but still. Were you sending me links to that last time? Because I thought that was... I think I wanted to see that. Someone actually... This is actually another shout-out I want to give. Speaking of other people being inspired by my stream, which I think is the coolest thing, by the way. Thank you guys so much for sharing that with me. Someone else... I'm just checking my Twitter. Someone else posted... Ryan Levick posted a link here. I'll give you a link to the tweet. He did a Chip 8 emulator in Rust. There's that link. And shared it with us. I thought that was pretty cool. If you haven't done an emulator, I would actually recommend Chip 8 too. Like, you don't have to start there, but it's not a bad starting point. A lot of people will say it's too simple, and I disagree. Because I think you still get the idea. If you, like it is still an emulator, especially if you do audio as well. Yeah. Okay, yeah, so now in main, here, we need to not call power on reset. So this is a little nicer now. I'm going to create a mutable 64 by sending it to pifrom and just have it run an instruction. I like this. Yep, so everything runs as it did initially. So I'm just going to commit this. Yeah. Okay. Cool. That's all like the issues that I want to go through first. So looking pretty good. Nice. Oops, that is not the file I wanted to look at. There we go. Here's our CPU datasheet again, which has been our most useful document, perhaps second maybe to TJS. TJ Piden? Chipiden? I don't know how to say that. I'm also inspired. I'm going to write a GBA emulator in Rust. Cool, I'd also love to see that. Sindev, I love Pi. Interesting note, the Nintendo 3DS is weird in that any memory that gets written by the CPU, which is actually a slave to the second CPU, I guess the second CPU would be a watchdog or something, becomes write-only and read-write-only and cannot be executed, so you have to use a ROP chain to run an exploit to get to the secondary, or to get into the secondary CPU and get that CPU to write the memory in order to hack the 3DS. That is very interesting. Um, little note on a ROP chain. I can't, if I remember correctly, a ROP is actually just like something that already exists in memory that you like try to take advantage of it being there. Like it's part of some other piece of code, and you have these little bits of other chunks of code that you try to navigate around. And that's what you mean by ROP chain, is you try to like jump between a bunch of them or gather a bunch of them in memory in such a way that you can actually execute them. Those are always cool exploits. Yeah, so let's actually work on running this next instruction. Another thing that I'll want to be thinking about soon, that I probably won't get into today just because I'm feeling a bit lazy, is actually setting up sort of like a proper way to debug this stuff. Like right now, I'm just kind of doing a bunch of hacky stuff, like, oh, we'll just throw some prints in here and we'll just try to get through some stuff. And like right now, I'm just printing like the names of the instructions and then the value of the PC. And that just helps us to sort of see where we are in the PIF and just like, it's not like a full disassembly that would be a little more useful, but just like gives us enough that we need to move on. And it's also like not conditional. Like I'm just printing this, just every instruction that we run. And again, this stuff is just kind of hacky as we're moving through this, but we can clean that up later and do like a proper debugger that we can like I want to have a nice interface to that kind of debugger. So we can either do like a command line interface, so we can just like run it and then like do a key combination or something to like go into debug mode and then start like stepping through stuff. I think that would be really useful. And also just be able to print things and do all that conditionally. So I would like to have some kind of interface like that. And I would also want to abstract it so that we can have, the command line interface to the debugger, but also like maybe GDB, or I really want to do Pro DBG, which is a really cool debugger that Daniel Collins is working on. I normally give him a lot of crap because it's not ready really for me to start using it yet. But I have been watching the repo and he's doing a lot of good commits, trying to move that project to Rust, and it looks really cool. So shout outs to him for working hard on that. That is the first debugger that I want to integrate with when the time comes. Yeah. So let's actually look at this instruction here. This was, as we remember from the disassembly, this is going to be store word. So let's go in here, just search SW. And here we have the load store instructions, but I really want to go down here. This is the page I'm looking for. Daniel Collins is getting there. I'm just stoked for it to be ready. By the way, guys, another tangent, right? I've kind of been thinking about where I want to go with this project, and I mean, it's still a ways out because I still just want to stream like us going through this process of really trying to get just all the little bits and pieces ready and actually getting it to running code. At some point, though, it's not probably going to make that much sense to live stream everything. Like, I think there'll be a lot of like bug fixing and debugging. I think at that point, I'll probably stop, being so critical about having like only writing code on the stream, and probably just sort of try to make it a little more community driven, because I do want this to be like a really good Nintendo 64 emulator in the long run. Even though right now I'm just kind of cutting some corners just to try and make it like a better sort of streaming project. But I just kind of want to let you know that that's kind of what I'm thinking right now, long term, that I do want to do that. But of course, I think we're probably like 20 streams away from doing that, because it'll be a while before we actually get any kind of peripheral support, like any kind of actually good emulation going. So that's just something I've been thinking about the last couple of weeks. Just to let you guys know. For now, though, I still want to kind of keep the PRs and stuff just to small, minimal things I can go over on the stream and, optimize for the stream viewing format. Or the stream ranting format, as it's been more like today. Colin says I can hot reload Rust code on it now, which is great for rapid coding. Yeah, I saw that library. I can't remember what you called it, but it was he wrote a library for sort of dynamically loading Rust modules that handle a lot of like cross-platform file naming issues, that kind of stuff. That looked really awesome. I'm actually considering doing a demo engine using that, but we'll see how that goes. Yeah, so let's actually do the store word. So we'll go into our CPU code here. Yeah, Colin just pasted. Hey guys, sorry about that. I looked into it. I'm not exactly sure what happened, but it seemed to be quite momentary. Anyway, I wanted to work on this SW instruction. Cool. SW. So I'm guessing that this is basically going to be the same as load word, if I remember correctly. Except it's going to be writing instead of reading. And as I'm doing this, I'm also just kind of reading this exception list just to make sure like that the exceptions that we're getting here are like not going to be specific to this instruction. Because later, later as we sort of implement this stuff, this exception stuff, I want to do it in a really generic manner because I don't think there are any specific instructions that will actually like, I mean there may be later, but so far from the instructions we've seen, there didn't seem to be any of them that can cause very, very specific exceptions. This is stuff like TLB miss, TLB invalid exception, TLB modification exception, which is stuff that is just going to be general to what this instruction is doing, not the instruction itself. So we should be able to bootstrap those fairly easily. Same with bus error and address error. So it doesn't look like we have to worry that much about that. So what I'm actually going to do, this will be really easy. I'm going to copy this code from load word. Whoops, paste it in store word. And yeah, because we still have the same base register. So this reading here is going to be the same, where it calculates the virtual address and then gets our sign extended offset. And then here, instead of writing reg GPR, we're going to read this. And then here, instead of reading word, we'll store that. In fact, we can do the same. We can call this mem here. I don't know if I want to do that, but self.writeWord for adder. And then I'm doing a sign extend here, which we don't need to do because the word is only 32 bits. So all we should have to do is take mem as I32. So I think write word was U32, so let's do that. Okay. I don't think I implemented write word. I most certainly did not. Let's do this. By the way, we can remove that check ending in this note because that was actually fine. It's going to be in mute self this time. And the address, and then we're going to do the value. U32. No need to return anything from this. We're going to do the same, again, the same thing as this, basically. We're going to calculate the same physical address here. And this is this right here where we do actually the address remapping. That's what's going to end up generating these kind of exceptions here. At least these TLB ones. Actually, I think all of these are covered under that. Maybe not bus error. Not sure what that means yet. A lot of these things we probably don't even have to worry about for a long time as well, because if we're running code that we can kind of assume is valid, like if we assume that the ROMs that we're testing actually work, it's probably going to be all right. So yeah, just share my thoughts. And in this case, we're going to right word here, the physical address, and then the value. And it's very likely, I think, that the interconnect also doesn't have write implemented yet. Yep. So we'll go ahead and go into that. Whoops. Typing. Ducati, why are you using unsigned ints instead of signed? In general, I like. I think that's kind of a good question, I guess. I have to think about how to explain that. DTTYD, DTID probably. I think signed addresses don't really exist. Yeah, so that's the first part. Is that so if we look at like write word, there's two things that we're actually doing here. We have the address, which is unsigned, and that is unsigned just to be more correct. Like we actually have 64-bit addresses that are, yeah, it never makes sense to have a negative address. For values, it could make sense to have positive or negative values, but in general, when I'm like interacting with RAM, I like to use unsigned just because I feel like signedness is like extra semantics, if that makes sense, and unsigned is just like I guess it feels like a more raw number to me. Because the only difference in signedness between like a U32 and I32 is interpretation. So I don't know. I like to use unsigned stuff for that. Just feels more correct, I think. Oh, here. I have a note to replace the constants with useful names. We already did that. So here, it looks like we're doing the memory mapping here. And we're basically going to have to do that again, but I think I can abstract that. Especially because Rust has references. So I think what we'll do here... maybe that doesn't work too well with big Indian stuff. I think it will, actually. If I were... Yeah, I think I could see how this will work. Do some on-the-fly refactoring here. Let's call it memmap for now. Not sure what that means yet. It's going to be in mute self because this is possible this being mutable. That actually might cause some problems with this. Might have to make read word mutable. But actually, it's probably best that read word is mutable anyway, because I'm pretty sure that this hardware is going to have some strobe registers. And strobe registers, for you guys that don't know what those are, they're registers that, depending on, like most registers, you'll usually write a value to them, a specific value, and depending on what that value is, it will affect the hardware state. Strobe registers are these registers where it doesn't really matter if you read or write to them, but if you interact with them in any way, then something will happen. Like it's just like the value itself doesn't matter. It's just the fact that you're interacting with the hardware at a specific point in time. So if any of this hardware actually has strobe registers, then this will need to be mutable anyway, because actually reading a value can affect those registers. Also, that's going to be the case if we like read a hardware register in general, because that hardware will have been doing something in the meantime since we last read it. So we're going to need to do like a sync kind of thing then as well. So actually, I think this is okay to make this mutable anyway. But what we want to do is return a mutable reference to a U32, I think. Not entirely sure how I want, if that's actually what I want, but let's see. Because this is why I'm like, this, not sure how that's going to look yet. Maybe this byte Indian crate actually has tools that we can use for this. Hopefully it does. But in that case, what's going to happen is we're going to do self.memmap adder. And that'll give us a reference, and we want to assign that value here. So we're going to say that is, actually no, in this case, whoops, in this case, all we want to do is just return that value. So that's all we need to do, is just dereference that. Yep. And then in this case, we'll do self.memmap_adder, and we're going to assign that to the value. So given memmap is correct, then that's what we'll do. I don't really like this name. Not sure what to call this. To do better name. Fixed. But yeah, so this here, I want to see what byte ending has that we can possibly use to help us there. Pull that up. Or did I say byte ending? Ugh. Hard to talk and code at the same time, man. Rest byte order. Blip. Yeah, because this big Indian thing is kind of the problem. Move away 000 saying it can't return a ref to a U32 unless your endingness matches desired endingness. That's what I was just realizing in my head. Because if we're going to actually dereference this like this and write to it, that's going to be a problem. But this could totally return a higher level object that represents something that we can read or write to. And then our speed might suffer, but we'll see. You know, I might just go for the code dupe here for now. Just because I think it's not going to be that bad, actually. I think our memory map isn't going to be that complicated. And I can always refactor this later. Yeah, I'm actually just going to go for the code dupe for now. Yeah, and then also, there was a small refactoring that I want to do here. First of all, I want to just do this. Just make right word always panic for now. Well, let's put this out. Here, in read word, the way that we're like checking this could actually also happen in match, I believe. I believe it was. Sorry about that. It's this. We can remove all this stuff. Good. Scale says 3 dots. Thanks. So many syntactic things that I forget all the time. So I didn't seem to like that we actually had an expression in here. Let me consult the dash, actually. Patterns, probably. Yeah. Ranges here. It could be just that syntactically you're not able to do expressions like this in ranges. Yeah, Dana Collins saying expressions doesn't work in match. But I could, we could get around that. Move away 000, probably most logical to me would be to make a function memory map adder that returns an address, where address is an enum with a pfrom offset, memory offset, etc. Yeah, we could totally do that. It would definitely help us to sort of dedupe the memory mapping code. I actually worry about performance on that, though, which might be a premature optimization, but I just have a gut feeling that that will not be very fast. In any case, where was... Did I make a mem map thing? Yeah, okay. With a pfrom end. I was cheeky, I could do this. DT tide is even legal to write into the pfrom. No, but we're gonna be have lots of we're gonna end up having a lot of different kind of regions that we'll memory map to. So yeah, we'll still need to do memory mapping on writes as well as reads. Skye is saying, pretty sure Rust doesn't have any overhead on enums, a single byte at most. Yeah, I'm more thinking about if it actually has to construct that object. You know, a single byte doesn't really matter in memory, but it's just like, I don't know. I don't necessarily trust how much that'll get optimized. Again, might be premature, but that's what I'm thinking. I really like to have like the start and end be sort of non-inclusive, but I think I actually might change this just for the sake of doing this. Which sets a precedent that I'll continue to do that from now on. I think that'll be okay. Dana Collin, enums in Rust works like unions in C. But wait, 00. Enums are on the stack like everything else in this box it. Yeah, again, it's still going to be overhead to actually like construct it a certain way, and also do the matching on it later. But Skye is just do it and then fix it if it's slow. I'll probably go with that. Maybe I should just call him Spoon. Yeah. Let's actually do that. I'm convinced. So we'll just make it local in here. No real reason not to. And we can just call it address as well. I'll actually call it adder, because that's something I use elsewhere. Yeah. This would be a UP2. Well, so we'll have the pfrom, we'll have a couple other addresses as well. The status reg. And then we'll not cover the unknown case, because for now we'll just panic. I think that'll be okay. So then we can do this. This actually shouldn't need to be mutable if it's just a memory map. Oh yeah, it doesn't need to be mutable because we're going to return a... wait a minute. So if we do the memory mapping like this and we return an address, then what we've done is we've encoded like the address like this, which makes it nice because there's some of that remapping that we don't have to do in both functions, but we'll still need to do these matches in both. But I think that'll actually be okay. We'll go for it. We'll just see. Doesn't hurt to try. Under U32. Yeah, and then that will basically be this. Doesn't matter. And I think it's okay to just remove this, so that this will look pretty nice. I think that'll overflow. I'll put it on the next line. Good enough. But this is kind of a bummer that we get stuff like this. Skid is saying you could have a trait with read and write, and then make structs implementing that for PIF ROM memory, etc. Yeah, I was considering that too. Like the address could actually be readable or writable. Maybe I do that. Maybe I do that. And again, maybe it's probably premature to be even thinking about like optimizing at that level right now. But we are writing an emulator to some degree. You just have to think about it a little bit. But let's do this first, and then we can make it like writable in a sec. So. Oops. In a real system, I don't think this would panic. I think the write would just be ignored. But this will be useful for us to debug. This is the kind of stuff where like, this is the kind of like warnings and stuff that you want to print. We don't really have a system set up for that yet. I'm not that concerned about it. Yeah, shouldn't be anything else. I mean, one advantage of having it done this way now is that if we're ever missing one in either of these cases, like if we read or write to a new place, we add something to this address thing, then it'll make us implement that for read and write word. That's nice. Cool. That should do it, except that needs to be self. And write status reg is not implemented for RSP. Phone. I'm gonna panic for now. because we don't know if it's actually going to write there yet. We also might want to have less specific read and write methods for the RSP later. Figure that out. Yep, and now we get an unrecognized pattern somewhere, and that's going to be an interconnect. It's going to be right here. Cool. Actually, and there we go. Panic that writes to RSP status flag not yet supported, so it actually does write to that register. That's pretty nice. Before we implement that, I'm still kind of thinking that we might actually want to make these addresses writable. Because I think that's fancy. Even though it might end up with like dynamic dispatch or something. Void00, there's an unimplemented str macro. Hey, cool. Didn't seem to like that. Does it not have that str variant? Or is that newer? Because I think I'm on, I'm still on Rust 1.6 nightly. Wu says, yeah, maybe no str. I'll just go with regular panic then. Not a problem. Yeah. This guess is you should probably update that. Yep, I know. I'm on a slightly older Rust, but just haven't had time to look into that stuff. Yeah, what am I thinking? I think actually if we do like read and write on these adders later, I think that might. Yeah, I don't feel like writing that right now. Or maybe I do. I mean, the thing is that actually if we add, when I think about it, like if we add read and write on those things there, we'll end up with something like let adder is mem self.mem map adder. And then we'll do like adder.write value. And then in adder.write we'll have this code. So it's not really going to help us that much, actually. Chikamishka, why don't you just update it? Because it'll take me some minutes to do it on stream. I don't feel like it right now. Relax about my Rust version, guys. It's okay. Yeah, so let's actually look into actually running that stage rig. Let's get I shall not. Awhile have write on adder take a single interconnect parameter. Why would that help? Oh yeah, because you wouldn't actually need to pass the adder. But you do need the bits from the interconnect for that to work. But again, I still think like having read and write on the adder is basically just going to be moving this code here and here up to here. So it's like we haven't really saved any code by doing that. Limit is double zeros. Yeah, so you don't have to access the interconnect, but still, I really think that adding the read and write on the adder doesn't say much now that I've seen us write this out. But this is at least nice because at least we get like these ranges and stuff here. And by the time you get these, you can have very specific errors. So at least we don't get like the error proneness of doing this multiple places. And the compiler will help us make sure we covered all the relevant cases here. So it's still probably useful to do this adder thing here. Especially because actually if I'm that worried about optimization, I can inline this stuff. So a little indirect, but... And again, if it's too slow, we can fix that later. Yeah, so now we're actually going to look at this write status reg. So I'm going to look up a doc really quick. Do I have another Firefox window open? Yes, I do. Hold on. Header docs. I can't remember which one it was. Is there a map? Just can't quite remember where this was. There's Laxins for hardware docs, which is pretty cool stuff. Yeah, LVM probably inlines half this stuff already. Yeah, it might. It's definitely my C++ brain talking when I'm worried about optimization. Really hard to unlearn that stuff. So I was hoping that we could get to the signal processor. Some info about that register. Let's dig in through docs. And did you guys know you're not even supposed to whistle songs that are copywritten if you're on a stream? I think that's crazy. Here are some RSP outputs. Okay, H here has a memory map at least. Let's look at that. TJS also gave us a nice link. Thanks for my map. Cool. That means we have 2 docs for this. Is good? Yeah, here. Yeah, so this is the doc we looked at last time. I also want to look at this other one. Oh wait, that was the one I just pulled up. Okay, I think these are actually the same doc. Which is cool. This is really, that's insane. Yeah, you literally cannot whistle like a copywritten melody. Crazy the things you can and cannot broadcast. But it does make sense. Copyright's about control. Yeah, so reading, we just, I guess these are the various bits that come back when you read it. And I think all we did was return 1 last time when we read it, just to simulate the halt bit, which is bullshit, but it'll work for now. For writes, it might get a little more involved. Actually, what I want to do is I want to print the value. That's it. I can't even remember the printing syntax. It's ridiculous. That's not it, is it? No. Yeah, that's what I was after. I want the hash. Can't remember why I want the hash. I think the hash gives you hex. That's why I want it. So the format module apparently has. Yeah, there we go. Thanks for away00. Somewhere in here. It's actually even faster if I just look at this. I think it's where. It's N64 that did this, or was it the CPU that had this? I think it's CPU. Yeah, that's this one. So when I X, this is actually what I want. This full format here. Yeah, I just want to see what it was writing. It was writing hex A. Oops. This is the important bit here. 0101. I just want to see what bits it specifically interacts with. So this is, it looks like when you write this and you set certain bits. Actually, TJS, if you could verify what I'm reading here is correct, if I'm interpreting this correctly, because it looks like if you set specific bits, like if you set the 0 bit when you write to it, it will clear the halt, but if you set the first bit, it will set the halt, which is really strange to me. I would almost expect like it to be one of these bits actually represents the halt, and whether or not it was 1 or 0 represented the value you actually wanted to write to it. Because the reason why, like, that's what it looks like this is telling me, but that's really weird. Like, do you know of any corner cases where, like, if you set both, what happens? Is that just, like, undocumented? Because, like, if someone wrote 1-1 here, then that would both clear and set the halt. It's like, what's the halt after that? Ah, it's just, that's good insight. He said it's so you don't have to read that status over the bus. Because, yeah, so what he's saying is that if you wanted to, yeah, this is actually clever. So if it was a one-to-one representation where, like, one of these bits represented the halt bit, in order to properly write the status register, if you want to just change one bit, you'd have to read it and then modify it and then write it again. And that can, you know, have a number of different disadvantages. But in general, if you want to like set a specific bit, all you have to do is write to it then, or clear a specific bit, and that's it. That's pretty cool. As I said, yeah, as TJ is saying, you can just write to the bus once, and it's a lot cheaper. That makes sense. So in particular, what this is doing then is it's setting the halt. Looks like 101. So it's setting the halt and then clearing interrupts. It's a bit funny that it's setting the halt because I believe the code like already assumed that it was going to be 1 and waited till it was 1. So I think it's kind of funny that it's setting that, but that's what it looks like it's doing. Inter I'm just assuming is interrupts. But right now what I'm actually going to do is actually ignore this. Because what we found here is that our plumbing to the RSP is correct. But I kind of want to get through more of this ROM and see if we can, yeah, see if we can try to start implementing this RSP stuff in one go. Just because, again, as we saw when I was doing like the coprocessor registers, there's a lot of stuff we have to model here. Maybe I do just want to sit here and do this. Not really sure. So I should just do this. Just model these 2 bits. It's not going to hurt. Assuming that that's what these are going to be. Yeah, default's gonna be fine. Except that actually we want this to be 1. So we're actually gonna not draw our default in here. Continue. Yeah, right here. Oops. This is the kind of stuff actually that this would be a really good place for actual hardware test, because we could actually, actually it wouldn't be, because we would have to have a custom PIF or something. This actually be a good hardware test. I was thinking about like how we could actually find information about the default values of these of this register. Might just be able to like Google it and find it somewhere, but in any case, these are probably not terrible defaults. Doing some of this stuff. But did I never do reads for these registers? That would actually make sense if I never did this. Ducati's getting sleepy. He needs to go. When will I stream again? Maybe sometime this week. Probably next Saturday at the latest. I think I'll say that because I this coming week is also really busy for me. So we'll have to see. Faster HT, using the same methodology, could you emulate something like a Pentium Pro or other old CPU? Sure. There's a lot of ways that you can write emulators. One of the things that I've been ignoring here is like cycle accuracy and things like that. And if you ignore that stuff, you can basically just interpret stuff like this. Eventually, if we want to make this sort of like a production quality N64 emulator, we're going to look into dynamic recompilation. We'll want to emulate things that way if possible. In terms of speed, I think. Maybe we won't have to, but still interesting. But yeah, this method will work for lots of different kinds of CPUs. It's not really a very strict method either. Yeah, so let's just do this. One. Yes. 0. That'll do. Tesher HT, I'm not sure if you answered this or if this is something you openly give out, but curious, what do you do for your job? I work for a company called Fuse, where I'm a developer/developer evangelist. So I do like workshops and training and stuff for a product that we make, which is also called Fuse, that helps you build awesome mobile apps. So if you go to fusetools.com, you'll find a lot more stuff. I'm pretty open about where I work as well because like I do like tutorial videos, so you're gonna find my face there anyway if you dig. Okay, so this. Yeah. That'll be okay. So then the writes, let's just implement. We'll leave the remaining bits. We'll just do the bits that we found here. This will be kind of jank, but dude, oops. Actually, I do want that for a reason. Yeah, we're going to do self.halt. And I guess for the corner cases, we'll see. Right. Again, these corner cases are probably not going to be that important, considering the code that we're going to be running through this thing is likely to be correct. But, you know. Just clear interrupt on this one. Yeah, then we're correct here. Oh, no. They're broke. Who knows what that is? TJ probably knows. It's false. That's all it has on here. Well. Hopefully that's correct. It should be alright for the first write, though. Actually, what I want to do is, if there are any other bits, I'll panic on this. This was 32 bits, right? Yeah, we'll be okay then if we do FF, and the last 4 bits F0. Yeah, it's not 0. Let's try that. Good. That way it'll tell us if we screw something up. I'll show you to see what keyboard we're using. That's Corsair K95, I think. Cherry Reds. Yeah, K95 RGB thing. I believe it's Cherry Reds. Might be Cherry Browns, but they feel like Reds. What was I fixing? Yeah, initialization, because we called default on the RSP, and now it's new. Whoops. There we go. Cool. So now we got an unrecognized physical address. And that makes sense. This is probably where that SW is writing to. Yeah, so AT was one of our registers, and then 16 was, I guess, the offset after that. That's weird that then we get hex 18 here. Bit unnerving to me. Let me go ahead and look at something again. I'll eliminate it with this. This might be correct. I'm going to assume it is, just because I don't think the card I wrote is that ridiculous. And let's just see what is actually, assuming that this address is correct. Let's check out what it was actually writing to. Here, it was writing to the DMA BusyReg. That's weird. Oh, no, never mind. I was wrong. So it looks like we got through the store, and of course we did, because that's what was writing to the status reg. Clearly, that's why we implemented that just now. But then it loads another upper immediate, and then loads a word from there, so it's checking if the DMA is busy. And that makes a lot more sense. If we look at our disassembly here, we're going to see the same thing. After the store word, load upper immediate, and then load word. So it's actually loading this word here, 24, and I believe hex 18 is 24. Yeah, that's correct. Okay, so good. We're loading from the correct address. So now our memory mapping will need to know this stuff as well. So this is const sp DMA BusyReg. And I'll, I guess, try to start aligning these. Be fancy. 0404 018. Cool. I'm guessing the DMA will not be busy right now. Call in console calc tip, use command 1 and 3 to switch between your mode. I did totally remember that as I clicked the button. This tool is awesome. Okay. So now we'll also need the SP DMA BusyReg. Whoops. And here, cool. Whoa. That probably won't work. This is a read-only register. Actually, we'll do it though. We'll model that with a function here, and then we'll like panic or warning later. I think that's okay. We'll do it on the RSP itself. DMA BusyReg, and this will give us a U32. We need stuff. I won't make these mutable till I have to. We'll just say it's not busy for now. That'll be okay. Function writes DMA busy reg. Yeah, this sucks. Value. I'll do it. Oh yeah. And I did some underscores instead of some periods here. Because everyone types like an idiot when it's live. So what I'm guessing happened here then is it probably was checking. Again, I didn't really read the code here, but I'm guessing it was checking this register to make sure it. If we look at this here, it's going to load that register and basically check if it's 0. And if it is 0, it's going to execute this instruction in the delay slot, which is going to basically help us reload the address. And then it's going to check it again. So this is just going to loop until the DMA is not busy. That makes sense. Then we do another LI, load immediate, which is actually load upper immediate, I believe. Let me get to where this branch was. Or, wait a minute. BQL. We should have had another one of those. We did the store word, load up immediate, low word, and then suddenly this was unsupported. I could have. Oh yeah, this is not equal, of course, because we want it to be 0, and this is not equal. So I'm guessing again the BEQZL. That was a shorthand for BEQL, where one of the operands was 0. I'm guessing the same thing is going to be the case with B and EZL. Yeah, Colin is pointing out exactly that, what I just realized. Definitely. Okay, so B and EZL, and that makes sense. Yes, because again, we're waiting for, we're going to branch if it's not 0, because we want it to be 0 before we move on. So cool. So let's go ahead and look up that instruction in our data sheet. It's going to BNEL, I'm guessing it's going to be called. Here you go. Branch on not equal likely. Or was it BNEZ? Sorry. No, this is correct. We do want this one. Ah. Because one of these registers is going to be 0. Or it's going to be general purpose register 0, which is going to give us 0. So let's go into our opcodes. It's going to be right next to BQL. Yep. BNEL. Another type. QRAM is saying, yeah, BNEZL is a pseudo instruction for BNEL with R0 as the first operand. And that's just going to make sense. So we are just almost flying through this PIFROM now. And I'm guessing we're going to end up with a lot of code reuse here as well. Or at least an opportunity for code reuse. I'm going to duplicate it first. Change what I need to change. And then we'll refactor. Yeah, so all this looks like it's going to be exactly the same, except it's going to branch if they're not equal. So here. Nope. Kind of thinking how I want to abstract this now. I'll probably do a branch. Are all branch instructions, do they all kind of follow this source target offset format? Because if that's the case, this will be really easy to abstract. So a couple of them, it looks like they have specific, like the x is like less than 0. So instead of a register here, we had a specific code there. Right, so the decoding is different in this case, but that's a separate part of actually. Yeah, a lot of these branches are encoded that way. Branch on less than or 0 to branch or less than or equal to 0 likely. Oh, what a fun instruction name. Yeah, but actually, here's what I want to do with this. Because in the cases where we're like doing less than 0, that could be the same as less than. So what I actually want to do is have the two. Here's what I'll do. Let me just kind of write it. It's gonna be a mute self, I'm sure. So what we want to do I always forget the syntax for lambdas. And especially the data types. This. What I'm going to do is I'm going to make a branch instruction where you pass in a lambda that will do the conditional for whether or not the branch should be taken. And then the rest of the branch instruction will be the same. Neon Fuzz, how far along is this coming? We're still working on the CPU, and we've kind of touched on some of the peripherals. A little bit on the signal processor, not a lot. So we're still quite early. Yeah, and then we'll do where going to be a function where we take in U64 probably, because those are our general purpose register sizes. So we'll do U64, U64, and that will return a bool. The Fuzz, crap, my audio isn't working. Can't hear you. Is it working now? I'll answer that question again when it's working for you. Yeah. So I'll take this so that each branch will actually pass in a lambda that will do the conditional, and because the actual function that we're passing in here won't change, it should be able to optimize that, especially if we make this inline. Crazy says function once if it only needs to be called once. I am not sure about the differences there. Closure types. Function once, closure can be called once. Closure called as function once can move values out. Can move out values from its environment. Function mute, the closure can be called multiple times as mutable. Closure call function may commutate values from its environment, right? The function in the closure can be called multiple times. Yeah, we don't need that. We do want F once. Cool. Crazy says do F and mute, but I shouldn't need to. F and once is what we need. Yeah, there we go. Yeah. F and once can use move closures. We won't need that. We're just going to pass stuff by value. So maybe I actually do want Fn in that case. Just because I know we won't be moving anything. I'm not sure which one I want to make that most specific. What do you guys recommend? If we won't actually be moving anything into it, I'm not really sure. Also, we're going to end up doing a little bit different stuff with the branches to actually get these LHS and RHS. Left-hand side and right-hand side for the actual branch. But we'll get to that when we actually come to branches that will do that. Don't need to be more clever than this for now. Oh, actually, we'll just call this RS and RT. Crazy saying do F in once just because the more general type. Whoops. Hit a hotkey. And the other should just course into it automatically. Sounds good. We do want to inline this. And then here we're going to do Whoops. I'm just a master at hitting the wrong hotkeys today. No matter. Yeah, and this will do, what was it first? RSOT. That should do it. So that's cool. And again, because these should be inlined here, the actual branch function, and then that makes this lambda constant, it should be able to flatten that. So we shouldn't have any extra runtime overhead for using that. And then of course, branch actually needed the instruction. Probably pass this in as our reference. Shouldn't matter since we're going to inline it, but that script implementation, of course it does. Yeah. Cool. Seemed to work. Now we get an unrecognized physical address again. So this was after a second store word at 50. Whoops. So now we get to look at what that was. 4, 6. So it's 0460. Okay, so this is the peripheral interface registers. Interesting. And here we have the specific ones. Wait00, make instruction implement copy using derive and pass by value. You wouldn't want to pass the U32 by reference, you shouldn't with instruction. Yeah, did forget that that was a new type. So that'll be okay. We'll do that. Whoops. Oops. Here we don't need to do that. There we go. Dash HT made a joke I didn't understand. Yes, we want to derive copy. And I think that will make us derive a couple other things as well. Yeah, clone. No problem. Cool. So that's a little cleaner. That's nice. I just saw struct and I'm like, oh, let's do it by reference. Did forget it was a new type. This guy, yeah, okay. So it looks like we're probably reading the PI status reg. That makes sense. See what it's doing. Let's go to our mema. Starts having us for these. This is going to be PI base reg. Oh, 460. Dash HT did not actually make a joke. He's just saying what he's doing. Crazy92, are you even encouraged to use inline always manually? Isn't the compiler pretty much always smarter? Again, it's totally my C++ brain being like, you should inline this. I would need to actually check the disassembly. For now, I just feel kind of comfortable like inlining it manually. Because the thing that I'm worried about is that if I don't make sure that that's inlined, then I don't think we'll get those lambdas flattened. And yeah, as Daniel Collin is saying, when it comes to compilers, the answer is always it depends. And in general, I worry more about those lambdas not getting flattened than I do about blowing up my instruction cache. So, it depends. Way00 says I'd recommend inline instead of inline always. I'll go ahead and change it to inline just for the hell of it, but again, Daniel Collins says only one way to find out. He's referring to the disassembly. Where was I? Shows here. I have some other inline always, but we'll leave them. I don't want to be, there's certain semantics like these too that I don't want to get too hung up on, guys. Like it's okay if this code is not flawless. And okay, so you guys are also talking about monomorphization will happen regardless of inlining. Yes, I'm aware of that, and I'm aware of, like, because the f is function one stuff means this template, so we'll always compile special code for those functions. But will it flatten that specific lambda code into those, or will it compile a function that expects a function of that same type and then still pass a function pointer in? You know what I mean? So there's still another level of flattening beyond the monomorphization that I'm talking about. So like it'll still monomorphize the template, but it might still pass in a function. Crazy 92, it will not pass a function pointer. I would love to see some disassembly on this. Not that I don't believe you, it's just that I would really like to understand this better. Crazy 92 said it will put the lambdas code directly in the function. Does it do that for every call or every... I guess it would do that for every call, wouldn't it? Maybe I'm overthinking this. Because I'm used to things like this being handled on the actual type. Because that's all that this is actually guaranteeing, as I would read it, is that this says that whatever f is going to be a type that's compatible with this. So it's going to duplicate this code, monomorphize it over that type, not necessarily the specific instruction that I pass into it. I mean, wait, 00 says, it's irrelevant though, inline won't hurt in this case, getting back to coding and fun stuff. Thanks, but I am actually interested. Like this, I am somewhat interested. Because then too, each lambda has its own type though. See, that I didn't know. Then what I'm saying about this generalizing over the type and monomorphizing over the type would make sense. But because each lambda has a different type, then it will actually guarantee to inline that code every time. So that's actually the key information that I was missing. If you could, Crazy, if you could send me a link, if you could post a link to where that's described, I would love to read that. Yeah, status reg. Wait, 00, that's correct. Each lambda has its own unnameable type. Yeah, see that's what I didn't know. And that was the piece of information I was missing that would guarantee that this would always be flattened. So then the difference is that whether or not that this will actually call a function called branch that's been inlined with that specific lambda or not. And then it really doesn't matter. So now that I understand that, there's really no reason to inline this. Dang, I keep hitting that hotkey. Oh, that's funny. All right. Thanks, guys, for teaching me this stuff, by the way. Again, I would still love to see documentation on where it explains that lambdas become their own types, just because I like to read stuff. Yeah, so now we're going to do our memory mapping stuff with this register. Oops. PI status reg. So another thing I can do is I can start separating this memory map stuff. In fact, I can put it in here, which would be nice, because the interconnect wouldn't actually need to do that. You only need the interconnect when you actually change the memory. So I think I'm going to do that. And then it kind of makes sense that inside the memory map we can just map an address. I like that. RAM size might come with us. We'll see. Crazy pasted a link. Oh, I think it's in the. I was looking. I was gonna see if I can find it as well on Dash, but it's very common for functional style code to return closures in various situations. If you try to return a closure, you may run into an error. At first, it may seem strange, but we'll figure it out. Here's how you'd probably try to return a closure from a function. A factory, which will give us a function that takes an I32, gives an I32 back, and then we'll return this closure here. Gives us these long related errors. Size is not implemented for that type. And that type here, this is what you mean by unnamed. Avoid double zero. Right. So, since that is a trait, it could be various sizes and many different types can implement function. Easy way to give something a size is to take a reference to it as references. Size. We write this. Another error, lifetime specifier. Yeah. So this is somewhat unrelated in terms of the way it's teaching us this, but I'm guessing here, this right here is where it's giving us mismatched types because this is letting us know that we don't have a static function this, we have a closure this, which is the anonymous type. This is because each closure generates its own environment struct and implementation of function and friends. These types are anonymous. They exist solely for this closure. So Rust shows them as closure anon rather than some auto-generated name. The error also points out the return type is expected to be a reference. Yeah, which again is not that related. But this paragraph in particular is just telling us that each closure will get its own anonymous type generated. TJ saying, then you don't need to pub the consts. Yes, I did see that. So I'll probably just make those private now. This will be public, and this will be public as well. Yeah. Fancy. That's all we need to do there. Yep, map adder does not need any reference itself. Never actually did. Yep, and now we get the stuff about that these are non-exhaustive, which is okay. Okay. And then we have those not being covered here. And this actually wasn't the one that was complaining, it's these two that are complaining. Yeah, so now we actually need to model the PI. So I want to look at these docs. So peripheral interface is, I believe, also where the name PIF comes from. So I think it's kind of ambiguous whether or not it's PIF or PI. Maybe I'm wrong about that, but also this doc says PI from start, PI from end. Yeah, ours match that now that we've done the -1 here. I believe. Is 7C02048? That's definitely not it. I'll add a 0 to that. Alignments. Crazy 92. I got Rust code running on the Wii, by the way, so I guess I'll try getting Rustendo running on the Wii tomorrow. Oh, I would love to see that. Please, like, email me or something if you get that working. That's awesome. Cool. Yeah, so I guess sometimes it's just called PIF in this case, but in this case it's called PI. Maybe there is a subtle difference. I'm not sure. But we'll call it PI when we actually model it here, just to be more consistent with the docs that we have. Yes, right. Stays right value. And this is going to be another one here where when we do this right, it's going to be crap anyway. That'll be right. So there's nothing actually called PI that we've modeled yet, so we got to do that as well. RSP, PI, peripheral interface. I could call that peripheral interface. I think it's okay that I don't. Actually, I kind of want to. Yeah, I think I will, just because PI is a really bad name for anything. Anything that's two-letter name is crap. You could argue the same about RSP, but I think that's a little more common, like a little more well understood what that is in the context of C64 and C64. And I definitely don't feel like typing reality signal processor. Data Colin, someone ported LLVM to 6502, so soon we can run Rust on C64 also. If you can get Rustendo working on a C64. That just means I need to do a 65C816 backend and get it working on SNES. Nagari, it's getting late here. Catch the rest on YouTube. Good luck. Thanks for joining us. See you later. Yeah, so we're going to do peripheral interface. Yeah, also this super stuff. I actually do want to use super here. That'll be okay. Yeah, holy shit, that would be so slow. Playing 64 games at 3 frames per hour. Yeah, no, I mean, it's... Yeah, technical memory would likely be the bigger issue. Yeah, that's what I was thinking. It wouldn't work, and it wouldn't be great, but, like, it'd be funny to just be able to compile the code to say you did it. If the code would even fit in RAM. You'd probably have to add a basic stub to even load it. Yeah, I guess you could run an emulator with a fuck ton of RAM and storage. But again, memory addressing. Yeah. Believe me, you'd have problems. You could do some kind of banking stuff, I bet. Make your own little... Yeah. Yeah, no. Actually, I think I mentioned this in the last one when I was doing that SNES tracker, and I did the SNES audio unit emulator, and then I reused the DSP from that. I also, because I was only used the DSP for that, I was able to just like use as much RAM as I want. So in the tracker itself, you're actually not limited by your amount of memory. Because normally the SNES audio unit has 64K memory, so you're limited by like how many samples and code you can put in there by that 64K limit. But in the tracker, you actually want to relieve that limit because you want to be able to like try a bunch of different samples and only have it export the samples you use. So as long as you get like an indicator and it won't actually export unless it will actually run on the SNES, then I think that that's way better. So we're able to do that by actually making reusable emulator components, which is cool. And that's just a reusability in emulator components is generally something that I find is, they're generally not reusable. You know, Colin, you can bank switch up to 16 megs if I remember correctly. I didn't know that like 6510 would. Scale says Daniel Colin, why not more? It'd be because your bank value would be 1 byte. But I don't recall a C64 ever being able to address that much. The 6510, I think, doesn't have that built in at least. Maybe the, oh, what was it called? Oh, I can't remember the name of that chip. The memory controller in the 64. Can't imagine that would have allowed anything else either. I'm very curious just because it's rad, but very off topic. You guys check that out. I'll work on making the N64 emulator. Peripheral interface. Ferris. Here, just like you did with RSP. Do that for now. Drive default on this. And what did we have again? We had, yeah. Here's our stays reg. DMA busy, IO busy, or error. That's all it was for these 4 bytes. We can just return 0. And I'm guessing the DMA won't be busy, the I won't be busy, and the error is fine as well. At least for now. Right status reg. Actually, that's kind of interesting. You can reset controller and clear interrupts. I'll panic for now. See what happens. Yeah, and then it wrote it. Of course. What did it write it with? Wrote it with 3. Okay, so it reset the controller and cleared interrupts. That's cool. Just kind of looking at this. It's now that I'm looking at this in the status reg for up here. Somewhere in here. What was that? This guy. TJS is basically saying that a lot of these registers are just like cart timings and stuff you can ignore. You don't get discouraged because a lot of them are useless from the context of an HLE. Yeah, more just kind of curious. I just kind of want to see. I did want to read into those registers a little bit and just kind of see what these are about. In particular, this clear interrupt thing. I'm curious what that is. So I remember this this document here. Went over the initialize this stuff. I just wanted to see if it said anything about some of those registers, just to learn. Doesn't look particularly interesting. Look at MI interreg. MIPS interface. Does this read if like an interrupt has happened? And I guess the clear interrupt will clear that flag? Yeah, it's just saying lots of the controllers, RSP, RDP, PI, and SI, raise interrupts and set bits in that MI register. I'm guessing they don't do anything else. Oh yeah, he's actually giving me how this should be implemented as well. Oh no, they do raise external interrupts. They're very important. Says TJF. Yeah, so I mean, they will raise interrupts, of course, but I guess this will. When you write to this, you'll clear the fact that there was an interrupt, I guess. Is that like to acknowledge the interrupt? That's kind of where I'm like, that's not very well explained here. Yeah, okay, that's what he's saying. TJ is saying the relevant bit in that MI interrupt register stays high until you clear it. And that's what this is doing here. I think I'm going to ignore modeling that register for now. Warn on a couple of these. This part of me just kind of wants to get through enough of this stuff that we can like get to some ROM code, even if we're not implementing things fully. I think that's okay. And that gets us to at least another section of registers here. Interesting. If I'm reading this correctly, then it looks like we're actually reading whether an interrupt has occurred in the VI. The boss tried to make a Game Boy Color emulator. I got bored though. You should have continued. I would have been happy to test that. Or actually, because I've done a demo for DMG before. I don't know if it works in GBC. I think the timings actually don't. Some of them are pretty specific. I actually found a bunch of, or not a bunch, but a couple bugs in BGB. And they were really happy about that. Half-line is venter. Okay, so I guess you can, here you can read the current scan line, and I guess this is, we're probably writing to this actually. I can look at the code. Yeah, so we're storing it. So it's what I'm guessing this is going to be. 44012. Yeah. What I'm guessing is happening here is that this is going to be, I'm guessing half-line because this probably spits out video interlace. But we probably write a value to this register, and that represents which scan line interrupts will start occurring on. I'm guessing that's what this will be, if video interrupts are enabled, which I'm pretty sure they're going to have to be. Or maybe they just are generated anyway. We'll find out, I guess. I just kind of want to read through these. I did not realize there was some scaling factor stuff here. It's funny. Do you have burst? And if color burst enable on half-lines? Wow, so you actually have a ton of control over how you set up the video signal. Remember that a lot of these terms like color burst and stuff are going to be specific to composite video, which is its own can of worms. But it's stuff that we will not have to worry about in an emulator like this. Same with this kind of stuff. Horizontal sync width in pixels, color burst width in pixels. Yeah, that is, we are not going to have to worry about those. Gamma dither enable? What? I forgot I had this anti-aliasing stuff. That'll be special. Yeah, here I have VI width. The frame buffer, line width, and pixels. Those all want to probably emulate. Frame buffer width and height. I wonder what the origin is. It's probably where it reads data. Yeah, here. VI origin reg or VI DRM adder reg. I'm guessing these are just different names for the same registers. Judging after seeing these now. Yeah, this is VI width reg or VI H width reg. H is pretty superfluous there, so I'll call it VI width reg when I do it. TJS, you should also have anti-aliasing and other filters in the first VI reg. Yeah, it's like interesting. Yeah, and then that makes sense why this is VI current reg or VI vertical current line reg. That'll give you the current vertical line. Sampled once per line, that makes sense. LSBV current is a constant within a field, and interlace bonus gives a field number which is constant within interlace bonus. So I'll have to do some learning about how this handles like interlacing and stuff. Probably won't have a lot of games polling that pretty hard. Maybe we will though. We'll have to see. In any case, yeah, what this is telling me is that there's going to be an interrupt when the current half-line is venter. That's just vertical interrupt. Is that all it's telling me? Let's search that. It's the only place it's mentioned. But I'm guessing that that's what this is. That we're going to get a vertical interface interrupt when the current half line matches whatever value we're right to here. So the important thing is that we just need to store this somewhere right now. So that's going to be the video interface. So we're going to start modeling that now, I guess. That's going to be separate from the RCP. I guess it's part of the RCP, but yeah, one of the various components. Separate from the RSP and RDP, I'm thinking. What I meant to say. I know that I just wrote a part in there. I can call this interrupt half line. It's actually 9 bits. Make that EU16, and we'll just abstract reading and writing to it. I could totally get fancy at one point, and oh, that's 9 to 0. That's actually 10 bits. I could get fancy and make types like that, but I don't think I want to do that. I think that would just make things complicated. We can derive default for this, because if that's going to end up being 0, I think it's going to be okay. That's probably a decent default anyway. You want it to trigger on scanline 0. Yeah. Oops. Control video interface. We're going to want to. Actually, I'm guessing we're writing to it. Although reading it is just fine as well. Yeah, into it, right? Let's make this a U32 internally. If we're not going to get the exact number of bits, might as well use the convenient one. And here we do self dot interrupt half line is going to be value and 0x. Oops. Bits. That's. I don't know why I can do this matter. So F10 is going to be 512. Oh, 1024. Got that wrong. No, it is actually 9 because 9 down to 0. Actually, 9 minus 1, 511. I just want that in. Of course, this is going to be 1. There we go. This is 3. So go to bit 9. If it were, no, that's wrong too. It's 03FF. Whew, math, guys. Yeah, because if it were 7 down to 0, then this would be FF. But it's 8, 9, so we need the next 2 bits of this one. And as long as we ensure that this is the right number of bits when we write it, then we're going to be okay. So I think that's all right. So now in our interconnect, we need to actually have a video interface. Okay, and then we had a specific adder that we did too. Didn't we? Oh no, yeah, we were about to model that. That's what it was. VI is somewhere between here, right? Base reg. Cool. Cool. All right, so now looks like it's storing another word, 04400024 in hex, and that is going to be, oh, fun. H start reg. Yeah, horizontal video. Okay, so this is both the start and end of the active video in screen pixels. Cool, we're actually getting to useful registers here. This is fun. So I'm of course going to implement this as two different values. Yeah, I'll call them active video start, active video end. We'll find out later if those values are inclusive or not. Who knows yet? So it's going to be self dot, what do I call these? Active video start. shift left 16, or self.active videos end shift left none. Yep. And here when we write it, self.active videos start is right. Let's start with shift right 16. How many bits was that? 25 minus 16 inclusive. It's going to be 10 bits again, so that's going to be the same value. And let's do that again. Cool. Oh, thanks, Java. Yeah, and then I didn't actually map the address. So we'll do that next. We see X24 there? Probably because I didn't do this down here. Cool. Blasting right along now. So now it looks like we're going to write to another one. 440, 10. This is interesting. So this is the, we have the current vertical scan line here, and I guess reads will give us that, and then writes will clear the interrupt line. That's kind of funny. If a place says printout, I don't know what you mean. Yeah, it's via current reg. Oh, they're saying print out the values being set. We'll see that as soon as we actually get to writing it. Or, yeah. I'll worry about that in a sec, guys. I'm Rock Dota, hello. Hey there. Rockdodo says, what is this language? It's Rust. It's Rust. We can just return 0 for now. And then for writing it, we need to clear the interrupt. I'll just do a tutor for now. I think it's going to be okay. Did I not finish mapping that again? That is correct. Okay, now we got a different address. Yeah, Colin posted a link to wrestling.org. Or Dota, if you're curious about the language, check that out. So 4 to 5. So now we're looking at the audio interface. Cool. I mean, it's cool to look at a boot ROM like this. Like just to watch what it's doing as it's just sort of poking at all the different peripherals, making sure they're going to be in some kind of node state. I mean, that's really like the whole job of the PIF, except in this case it also does some lockout stuff, but we'll get to that when we come to it as well. But I'm actually going to take like a 5 to 10 minute break now, actually, because it's been a few hours. So I think I'll do that. And I'll see you guys. So it's 17:07 my time, 17:08. I'll see you guys at 17:20. We'll do a 10 minute break. So yeah, see you soon. Hey guys, I'm back. Hopefully that wasn't about right on time. While I was away, Emerald Dota said, "Is Rust a low-level language?" It's low-level in terms of that it doesn't have that much of a runtime, I guess. Like the code itself runs bare metal. It's not like interpreted or it goes through some kind of intermediate language. So then I would consider it a low-level language. But in terms of like the abstractions it gives you, I'm not sure if I would actually want to call it that. I think the more appropriate term or the more appropriate question is it a systems level language? And I think definitely. Or not I think definitely, it definitely is, if that's the question. So, hope that clarifies things. So we were about to talk to the audio interface, it looked like. And it looked like we were just going straight for 04500000, which is both the AI base reg and also the AI DRAM adder reg. Yeah. I'm not really sure what DRAM and RDRAM is, but I'm guessing it might be some like shared memory in the system memory that this will actually be reading from. Or maybe DRAM is some RAM that's on the RCP. I'm not entirely sure. In any case, it looks like we're just basically sending an internal pointer that's 24 bits wide. Yeah, to a specific point in RDRAM. So for now, all we really need to do for that is to start modeling the audio interface and just give it a register to store that in. So that'll be easy. We can derive default for this as well. And that's going to be, we can call this DRAM adder. I think that's okay. BDU32. Birkenfeld says DRAM is main memory. Okay, nice. Things I should know. Birkenfeld, I think it's just sometimes called RDRAM because it's RAM bus memory. That makes sense. DRAM is probably... never mind. Mark Dota, can I control any microcontroller with this language? If you have a compiler that'll compile Rust to your microcontroller's architecture, then yes. Ideally, it'll work anywhere you'd use it in where you could use C or C++. But there is a caveat that you need an LLVM backend at least to be able to build the compiler to put the code on your microcontroller. Yeah. Yeah, function read adder. That's 2030, so that's FF 24 bits. We gotta shift all these. Someone told me there's a shortcut, or a key command Emacs. You can actually do that automatically, but it takes like 2 seconds. Crazy92, aren't there also LLVMs for compiling to C, or LLVM backends for compiling to C? It'd be interesting to see if that could be used to compile to anything that doesn't have an LLVM-based compiler. It would make sense. Should definitely be able to do that. And she's just saying, I'm working on a project to get Rust running on a STM32 F205. I have no idea what kind of microcontroller that is, but that sounds awesome. Okay. TJ's ARM, cool. Crazy92, by the way, Rust formatting guidelines discourage using this column-based alignment. Yeah, I did know that. Is it back up? Is it back up? Should be good now. We good? We good? Looks like we're good now. Guys, really sorry for the stream drops this time. Can you repeat what you just said? It was probably about, yeah, I did discover that the Rust format guidelines discourage the use of like aligning everything to blocks like this. Probably actually because like when you add something that changes the alignment, you got to change all this, and then it makes like a really nasty commit message. But in general, I just think that this looks a lot better. And if we're going to actually be reading these values, I like this formatting here. So I think it's going to be okay that we do this. We're only doing it in situations like this. So I think it's fine. But yeah, I am aware that the Rust formatting guidelines discourage that. I think I'm just dropping frames every so often because normally I'm like I live in an apartment that my company rents out when I'm in California, and sometimes there are other people in here. So I think if other people are like streaming and stuff, I think it's just gonna happen every so often. So sorry about that, guys. I guess I did call these regs. Probably do the same thing there. The drops haven't been that long, at least this time. Oh, hey. Actually, guys, how do you set that up? Unrock Dota did the like bang GitHub thing, expecting to see GitHub of the project. How do you actually set that up on Twitch? Because that's a good idea to set up. Thanks, Crazy, for actually posting the link as well. I should totally have that set up. Okay, gotcha. So I guess I'll just have to set up that buffer next time. I'll make a note to myself to do that actually right now. Cool. Thanks for the tip, guys. I'll set that up for next time. Cool, so it looks like we're writing to another register, which is going to be this one. The AI length, the audio interface length. I'm guessing the way the audio interface works is there's probably going to be, like you've set up a loop buffer, and and the audio interface is probably just like has a read pointer in there that is just writing values, and then running them through the DAC. So I'm guessing that's what we're doing here, is we're basically setting where that is in memory, and where it is and how long it is. People finding friends in the chat. Yes, this was the AI length register. Let me just call this length for now. Interesting. Looks like there's a transfer length version 1 and 2. I wonder if those are different hardware revisions. I bet TJS knows. I know he's listening, so I'm just shouting out. For now, I'll actually just go with the. I'll write a to-do, and I'll take the 17 bits. Rock Dodo, I'm asleep a little. Have a good night. See you, man. Thanks for joining. Thanks for joining. Let me say that properly instead of mumbling it. Good to have you, man. Let's try that. Also says bottom 3 bits are ignored, so we're going to mask those out. This is no bits. Although if it includes 17, it's going to be a 3 up here. Whoops. And then the bottom 3 bits is going to be 15. Let's see. I believe. So if it were 15 down to 0, we'd have this, but 16, 17, another 3 bits here. I think that's correct. Oh, by the way, guys, I kind of wanted to ask you. Oh, Dylan says 3FF8. That's correct, because bottom 3 bits. Yep, that's correct. Good. That's correct. Yeah, guys, I was gonna wonder because I have like tons of projects that I actually want to stream, and I don't want them to be as necessarily as structured as this one. It's like sometimes I just play Stepmania and I just want to hang out with people on the internet, or sometimes I'm doing some reverse engineering stuff and like I don't want to like make a proper stream out of it, but I just want to hang out. So like, if you guys would hate that, let me know, and I won't do it. But I'm thinking about using this same account just with like slightly different branding for the different kinds of things I want to stream. So if you guys would or would be interested, actually any thoughts on that would be appreciated. Because the other thing I'm worried about is that the people who have subscribed to this, they're just like, I want to watch this guy make N64, and I don't really give a shit about anything else. Then it kind of sucks if they get extra spam whenever I'm streaming other stuff. But at the same time, I don't think it's that bad. Dana Collin, Skay, TJ said I'd be down. T-Launch Gizmos, I'd love that, sounds good. Cool, thanks guys. I'll probably start doing that. Maybe today, except I can't remember who it was that was saying that they were going to have the guy that was working on Citra was going to stream some Vulkan stuff. I want to catch that tonight if he's doing that. I'll probably start doing that pretty soon. Especially with Stepmania, because I actually play that game all the time. I love that game. Crazy. Wait, which guy sounds pretty cool? What? I don't remember his username. I can't scroll up because I had to refresh the page. I don't have a link. I asked him to post a link, but I followed him. Wait a minute. Hold on. I'll get the link. I did follow him. It does sound cool, and I'm totally all about promoting other streams that are awesome. Or that sound awesome. I don't actually know if it is because I haven't seen it, but it sounded really cool. Skate, you saw the AGDQ showcase of it, right? Yes, that's actually what got me into it. Like, I was sick for a couple weeks around then, and I just picked it up because I couldn't really do anything else. And it's been really fun. I'm a Twitch noob and don't know how to find my followers, or the people I'm following, that aren't necessarily live. ZMS rhythm games are fun? Yes, they are. They are addictive. Does anyone know how to find channels that I follow that aren't necessarily live? I'm so bad at Twitch. I only got Twitch for this, so it's like, I don't even know how to use it. And I like literally only follow other live coders and Stepmania people. And a few random speedrunners. Oh. It was the latest one I followed. It was the Sin Dev I Love Pie. That's who it is. Here, now I have a link. This guy. Ah. He said he was interested in streaming later today or tomorrow. He wasn't more specific than that, and I don't think he's watching anymore. He left. But I was also interested in watching that. I thought that would be cool. What he was doing is he was going to work on a Vulkan. I might have already said this, but he's going to work on a Vulkan video backend for the Citra, the 3DS emulator. It'll be a lot more exciting than this one because we're just not that far yet, but eventually I want to do stuff like that as well. Yeah, so I should do it for this, and I think, did I do the map stuff? No, I did not. cool. Oh, hey, we finally got another unrecognized instruction. That's new. Down at B8. Wow, we covered a lot of ground. Sick. Okay, so this is branch not equal. Oh yeah, of course, because we only did the likely ones. We didn't do the non-likely ones. So actually, on that note, I actually want to go back into CPU and change this branch function to branch likely. While we're at it. Then we'll hit up our data sheet. Check out B&E. There we go. Branch on not equal. The branch address is calculated from sum of addresses of the instruction delay slot and the so the address of the instruction delay slot. Okay, so the next instruction and the 16-bit offset. Shifted 2 bits left and time extended. The contents of the general purpose register RS and the contents of the general purpose register RT are compared. If two registers are equal, the program branches to the branch address with a delay of one instruction. So when it says with a delay of one instruction, does that mean it will run the instruction delay slot if the branch happens and then it will jump to there? I'm guessing that's what it means. So no matter what, the instruction delay slot will probably always execute. That's what I'm guessing. But is that not what we ended up with on branch likely? Right, because we did a... Also, this is kind of jank. Update the PC and then do the instruction delay slot? Or maybe that was correct. I don't remember. Because the... One second. C wrapping add. So what this is doing is if the branch was taken, it would execute the instruction delay slot and then jump if it was likely. Otherwise, it would skip the instruction delay slot. That's what this logic is encoding here. I'm guessing branch if not equal will just always run that instruction delay slot. She just says, I remember you taking great care to get that right. Yeah, that's probably correct. I feel like I definitely would have thought about it. I should probably write a comment about that, actually. Maybe not, but no, I definitely should. Here. I'm guessing the only difference between the regular instructions and the likely instructions is that the likely ones do this logic here where they skip over the delay slot instruction when it's not branching. And I'm guessing, actually, we still get that this doesn't happen in the regular branch instructions. Yeah, QRAM is saying that. Yeah, BNE and most non-likely instructions always executes the delay slot instruction. It did it because the first time I executed the delay in either case, that caused an infinite loop. You did, yeah, okay, yeah. Okay. Again, we're gonna just copy this and then see what we can abstract after we change it. Regular branch. The only difference is this. It's get 3 a.m. I'm gonna go to bed. Yeah, see you, man. Thanks for staying up. Okay. Danish is really hard to pronounce. Common notion. Yeah. So I think the only difference is that. Let's do this. Well, now I have to do is let underscore equals branch. That would have been here. Yeah, because this would have returned bool. I could also do this. Actually, no, because this branch likely. So I only have to do it on the branch one. May not be the most elegant thing in the world, but not sure I'm totally happy with that, but we'll see. See if it bugs me too much. Let's upload this one more. TJ says, doesn't branch only execute delay slot if true? In the way I wrote it. Yep. Good call. That's a good catch. That would have came back to haunt me. Probably would have read through it again anyway, but still. Definitely I was wrong about that. Okay, so let's do this. That's still good to keep separate. That looks nice. It's because I had it wrong originally. Because this is not the only difference. Oh, actually, you know what? I was correct. I was correct. Let me explain why. Let me put it back and I'll explain why. Solo Drew, what are you coding? I'm making an N64 emulator in Rust. I believe it says at least N64 emulator on my overlays up there. This is correct. We will execute the instruction delay slot if the branch is not taken as well, TJ. And the reason is because if it's not taken, we don't adjust the PC. And so the next instruction that it will execute is the one in the delay slot. If that makes sense. So in branch likely, if it isn't taken, or if it is taken, we have to execute that explicitly because that's going to be out of order after we've adjusted the PC. But then, yeah, after we do it, if it's not likely, we'll just keep going from where that was and we'll hit it that way. So I think this is all right. Also going to end up putting this on the other line again, even though it looks ugly. To keep my indentation better. Yeah, okay, now I need semicolons here. There we go. And now we get another unrecognized physical address. TJ, sorry to completely derail you. No, that's totally okay. It's really good that we double check that. So even if it was already correct, it's good that we took another look at it. Solo Drew, isn't that illegal? But I don't really care if it isn't. Making emulators is not illegal. So let's take a look at that unrecognized physical address. 04001000. Black Bomb. Oh, good to see you, by the way. Or see that you're in the chat. Oh, here we go. SP IMEM read write. Oh, this is the SP is a signal processor, so I guess we're writing to its instruction memory. Hey, cool. Is that like a buffer that we send to and then have it transfer, or is that just like what, or is that memory just directly mapped that we could just write to it? Probably just directly mapped. I'm guessing the DMEM here is the data for the signal processor as well. Cool. That means we're going to actually write directly to that, which is pretty rad. Cool. So let's go into adder. Oops, my map out here. Do sp imm with the offset in here. I'll just make it a U32. I mean, it could fit in U16, but I'll make it a U32. Not be that anal about that. It's funny that's actually past the base register. But that's alright. Just call it SPIMM. Yeah, but this is sick actually, because what this is doing is it's about to, I guess, write some wait a minute. Why did B and E take us there? One second. Looks like we're storing a word. Wait a minute. I think I know why. Because it's probably doing something with the delay slot. Hold up. Hold up. Actually, I'll do this first really quick. We'll do item start. Let's actually split these up. imm length. I have no idea if this is actually this long, but let's just pretend it is for now. There we go. QRAM says this loop of code is copying the rest of the code from source ROM in T4 to RAM T3. I do remember TJS telling us that it actually puts a bunch of code into the signal processor, and then that's where it starts running. But what's actually really sick is that like we're actually giving code to the coprocessor. I find that exciting. We'll do sp imm and cool. Okay. Oh, this is good. There will be a JR coming up that will jump to this code after it's uncopying. Cool. Very interesting. But that makes sense. I mean, I guess that's why we didn't. We're not getting any like invalid addresses while we're reading, because it's just reading out of the memory we already mapped, which is literally just the like the PIF ROM and stuff. I don't think we mapped anything else. So little Drew, I don't understand coding at all, but it's interesting. Cool. Glad you enjoy it. I mean, I try to at least talk a lot about like the hardware and kind of why we're doing what we're doing, but of course, I am also writing code, so we'll get a mix of both. Oh, we need an offset here. Black fun to see. I let my eyes glaze over and enjoy the pretty colors. Thank you for pointing out the pretty colors. This is I actually made this theme for Emacs. Mainly because the one I was using before looked really ugly with rust. Into Chica Mishka, what's the name of the syntax name? I called it Pasteltron because it reminds me of Tron, but also has a lot of pastel colors. I can get you a link to it on GitHub, but I didn't like publish it anywhere other than in my dot files. QRAM, yeah, this copy code and jump section will prove is a great test for your memory mappings. Chica Mishka, oh, you made it. Yeah, I made it. It was based off of this one I found called like Midnight Paradise or something. I can't remember who wrote it from. I have a comment in the theme. I can pull it up actually. Oh, almost to 200 stars on GitHub. That's cool, guys. It's really cool. Chica Mishka, nice. That's okay. I don't use Emacs anyway. I was just wondering. I still want to pull it up now. Yeah, it's based on Jim Mirberg's Tomorrow Night Paradise theme. And I basically just took that and just changed all the colors. So he did all the hard work of like naming everything and having the right mappings. And I just made it look better, in my opinion. Okay, so we're probably going to actually want to have that IMEM now. And actually, if we go back to memmap, I do want some of these to be pub. That's right. See, everybody at work hates Emacs. Almost everyone uses Vim. Watching me run Emacs, I don't know why people hate it. That's funny. It's just one of those rivalry things, I guess. I think Vim's a lot faster in general, though, but Emacs does a lot more for better or for worse. ZMS 8 makes it constantly swapping. Man, I love that. Not as much as I love the old quote that Emacs would be a great operating system if only it had a better text editor. I like that. I think Vim is perfectly suitable for coding, just as well as Emacs is. Or, oh, actually, yeah, we didn't actually need that. We didn't actually need to expose that. Yes, we did. Hold on. I know why. We'll get there in a sec. Yeah, I'll do U8 here. We'll use byte order again to actually read and write to it. Because it is going to be 8-bit aligned, I believe. We'll be okay. Bop. Box. There we go. Yeah, this is why I wanted it. I can never remember if it was the value or the size first. I think it's the value first. SP length to Black Pond. I've never been able to get into Vim or Emacs. I always found Visual Studio Xcode nice enough. I used to be a huge Visual Studio guy. But then I had to start using a Mac for work, and I tried Xcode, and I agree with Daniel Collin. I hated it, and like I felt so useless being away from Windows and Visual Studio that I learned Emacs. Like that's literally why I did that. TJ uses Atom. Atom's cool too. Same with like Sublime in like the more modern scriptable editor land, you know what I mean? But I don't know. I just like Emacs. The thing is that I wanted to use Emacs or Vim because like clearly they were time tested. And back when I tried Atom the first time, it was really slow, and Sublime didn't do enough. And I had a buddy that used Emacs, so I picked up Emacs. It's that simple. Yeah, what was that function called again? To something slice, to on slice, to box slice is probably what it is. That's what I'm after. Chicken Michigan, yeah, Atom was awful at the start. I guess it's gotten a lot better, but it was really slow when I tried it the first time. Crazy says Atom still starts up in like 15 seconds for me when I tried it earlier today again. To be fair, so does my Emacs, but that's also because I have some startup scripts that will go check package managers whenever I start it up. So if you ever want to collect data on me, there you go. Find when my IP actually accesses Melpa. TJ and Jacob both say Atom's gotten great now. I totally believe it. I definitely believe it got better. That's your HT. The thing that throws me off is when a server doesn't have Vim installed. I don't know what to do. Yeah, Emacs definitely does not have that advantage. You at least have Vi on like everything. Which is definitely an advantage. So we're going to do self.imem offset as size. Yeah, now we need the byte order thing. Into box slice. And the actual reading stuff for this, where is it? There we go. This is actually what we need to do here. This is actually wrong. Would have been right if we were reading U8s. But we're not. Hey, baggers! Emacs and Tramp, though. Awesome. Daniel Collin venting so much rage about debugger in Xcode. TJ, I'm pretty impressed with VS Code. VS Code is cool too. But it's no Emacs. Bagger's just been lurking in the shadows. Finally come out when the Emacs discussion started. Yeah, Colin, no need to apologize. There's a reason why I'm not using Xcode. Oops. Yeah, that'll work. I just need to pull that in here. Do I actually need byte order? I need to pull that in? I don't think I do. I think I just need big endian. Oh, no, I do. To get, to pull, read 32 and write 32 in scope. I do need this. Give me that trait. Recursive constant. Ha, yep. There we go. Length. Go back. So we needed, oops, down here we needed this as U size. Can you do that with const? I don't know. Oh yeah, of course, write 30, U32 needs the value. And this needs to be a mutable reference. There we go. Like fun. Here I am coding in Xcode like a peasant. Jacob Mishka, I used Genie for a bit so you can't sing as low as I have. I haven't even heard of that. Alright, we got another unrecognized instruction. Where was this? Oh, here. CC. Go back to our PIF. And there's our jump. Interesting. Really interesting, actually, for a couple reasons that I will go over in a second. But JR, it might be jump relative or something. Let's check this out. So there we go. Jump register. That makes sense. Program unconditionally jumps to the address contained in general purpose register with the delayed one instruction. So I guess the delay slot will also run. Yeah, Colin, we have a loop. Actually, I think if the guys earlier were correct, we have a somehow jump to some code in the signal processor. Which is weird, because why would we use the CPU to jump to that? I don't know. I have no idea. But let's start looking at this instruction. Oh wow, it's past 6 already. Man, Daniel Collin is up late, and so's Baggers. At least. I'm gonna implement this instruction, and then I'm probably gonna call it quits. Actually, I feel really good about the progress we made today. I think this was good. Oh yeah, we need I like that it says special, and then it's just these are special zeros. But they actually are, because these are, yeah. Special is like a special op, and then you use these last 6 bits to determine what it actually is. But that's just funny. Yeah, Christ is also up late. Man, you CET guys. That's awesome. Okay, so to implement this jump register instruction, my decoding isn't going to be as lovely as I wanted it to be, because we're going to end up with special here. Maybe that's okay. I'm not sure how I want to do that. That's what it was. Because we're going to end up with a couple instructions like this special one here, where these first, like the regular opcode is actually going to say that, oh, we need to look at something else. That means this opcoding that we have here kind of sucks unless we add special here, which is maybe okay. Our decode doesn't get as nice though, but that's probably all right. I think though, actually, before I dive into that, I think I'll actually call it quits now. I think that's what I'll do. Yeah, I'll do that. So I'm going to commit, and as usual, I'll end with questions. So if you guys got any, fire away. Oh, we did good progress today. At least it feels like it. Sick. Surprise, Dota, I have the worst timing. Yeah, sorry, man. It's a bummer if you're just tuning in. YouTube's good too. I can break up your marathons into smaller sessions. Yeah. That's the problem with the format, is it is long, but it takes time. So no questions this time? That's cool. I'll probably actually stream a little bit later tonight, but if I do, it won't be this project. I might go to Fry's, pick up a little webcam, stream some Stepmania, and stream my hands. But I might have plans with the other guys soon, so we'll see. The roomies. So I guess that's it. Again, this is probably one of the only times I'll actually call for pull requests. If someone wants to set up a Rust format config file for me, that'd be cool. Because I'm lazy. Delegating. Beyond that, I guess next time we'll continue on the PIF stuff. We'll figure out what this jump means. Actually start asking. President 2 actually has one of those configs, but didn't PR yet. Cool. I'd be happy if you did. Thanks for looking into that. Yeah. But I guess if you guys don't have any questions, I don't have much else to add. So thanks for tuning in again. Cry's92, but it'll kill your columns. Yeah, we need to not do that. I think there's options to like set the line width or something, or like the ideal width. I think setting the ideal width might fix that. If it doesn't, then we'll just not use Rust format for a while. We'll just put it off until I'm not streaming everything. There's only way with it doesn't fix it. Okay, thanks for looking into that though. I think I'll close that issue. Hold up. Just because for the stream we kind of need to keep the janky line widths. Yeah, and Fuzz, how late are you going until? I'm actually shutting down now. If I hop on later and do like Sit Mini or something, then I'll. Who knows? But I might not do that. Yeah, and Fuzz, any schedule is at random. It's semi-random. I try to do it at least like every Saturday. Usually PST 1 to 2. Today I think we started at like 2:15 PST. But it kind of has to be random just because like I don't know. How functional is Rust 64 so far? Not. Says Neon Fuzz. Yeah, it's really early. Like I started this a few weeks ago, and I've only streamed 6 sessions. So we're pretty early. I want to make it like a proper emulator, but it takes time. See you, TJ. Neon Fuzz, on one more thing. Do you know about Emacs region undo? I do not know about region undo. I'll learn that on the stream. Or actually, I'll probably just Google it, because I kind of need to go. Unless you can give me like a really condensed version of what it is and how to use it. Yeah, I think I'll just look it up later. So I'm going to go. Thanks again, guys, for tuning in. This has been really fun. I think we made a lot of progress today, and that'll, I guess, continue to go faster. Neon Fuzz, if you select a region, undo it, it undoes in that region alone. Cool, I actually didn't know that. That's pretty cool. Thanks for that. Yeah, the next stream will probably be... next Saturday, just because I have a really busy week this coming week. Maybe I'll be able to squeeze some time in, but don't count on it. After that, though, my schedule frees up a bit, so I'll start to do this. My goal is to do this like 3 or 4 times a week, but it just hasn't worked out that way thus far. But yeah, again, thanks guys, and I will finally push the button. See ya.